sketching linear graphs. There's two methods that we're going to use, the first being the x-intercept and y-intercept method. The other method will be the gradient and y-intercept form. So let's look at the x-intercept and y-intercept method. To use this method, we need to know what the x and y-intercepts are, remembering that at the x-intercept, y is always equal to 0, and at the y-intercept, x is always equal to 0. So the line is drawn by locating each intercept, and then we connect the dots by basically drawing a line right through the points. And like I said, remember that for the y-intercept, x equals 0, for the x-intercept, y equals 0. So let's look at an example on how to solve it. So in this example here, we're given the equation y equals 4x minus 12. And we're asked to sketch the graph using the x and y-intercept method. So let's just go back and remember the x and y-intercept method. So to find our x-intercept, we know that y equals 0. And to find our y-intercept, we know that x equals 0. Looking at the equation we've been given, we're told y equals 4x minus 12. So let's just break the equation down just because we know what the elements mean now. We know that our y-intercept is at negative 12, and we know our gradient is 4. Alright, so funnily enough, we've actually just worked out that our y-intercept is negative 12 by looking at the equation. So remember, the y-intercept is when x is equal to 0. So if we were to write that as a coordinate, so I'm just going to write here, finding the y-intercept, knowing that x is equal to 0, well, looking at the equation, we worked out that the y-intercept was 12, so the coordinate would be written 0, negative 12. But let's actually do it using algebra. So we've got y equals 4. Remember, x is equal to 0, so we know what that is. We're trying to work out what y is. So 4 times 0 minus 12, and y is equal to negative 12, because remember that equals 0. So we've just proved our observations correct in that our y-intercept is at when y is equal to negative 12. So now let's work out our x-intercept. And we know when it's our x-intercept that y is equal to 0. Again here, we're going to do a bit of algebra and solve. So I'm going to substitute y equals 0 into the original equation, which is 0 equals 4x minus 12. Remember, it was y, but we said, to find the x-intercept, y must equal 12. So now we're going to solve for x. So I'll just write solving for x. So the first thing I'm going to do is take that negative 12 to the left-hand side. So I'm going to have 0 plus 12 equals 4x, leaving me with 12 equals 4x. And to get x by itself, I'm going to divide both sides by 4, leaving me with x is equal to 3. So now I've worked out that when y is 0 for this particular equation, x is equal to 3. So writing this out as a coordinate, I'm going to have 3, 0. Remembering that our coordinates are always written as x first and then our y value second. So now we've got enough points here that we can actually plot our linear graph. Now, if you're doing this in your workbook and as part of your practice, make sure you use a ruler, because the linearity of the graph will definitely matter, being that the topic is linear graphs. Label your axes. Remember, x is our horizontal, y is our vertical. So now let's look for our points. So our x-intercept was when x is equal to 3. So I'm just going to put 3 there. And our y-intercept was when y was equal to negative 12. Now obviously my graph is not to scale, but don't feel pressured to, but just make sure that it does make some sense. So now I'm going to plot, now that I've plotted my points, I'm going to draw a line connecting the 2 points. And there we go. So now that we've done this, make sure to actually label our points of intersection. So we've got when x is equal to 3, so writing that as a coordinate, I'm just going to write 3, 0. And writing this as a coordinate, I'm going to write 0, negative 12. Make sure as well that you write the equation somewhere near the linear line, just so that we know that that's the graph that you've just drawn. Make sure you've labeled your axes as well, so you've got your x and y, and make sure they're in the right place, remembering y is our vertical, x is our horizontal. I'm going to be looking at sketching graphs using the gradient intercept method. So to use this method, we need to know the gradient and the y-intercept, which is in its name. So for example, let's look at y equals 2 on 3 times x plus 2. So from the equation, if we're following down where I've written 1, 2, and some other points, we can see that the y-intercept is at 2. So looking at this equation, we can see here that the y-intercept is positive 2. Therefore, we write the coordinate as 0, 2. Remembering that it's x first and then y. So from the equation, we can also see that our gradient is 2 on 3. So remember, our gradient, or m, is this here, which is in front of the x, and in this case we can see that it's 2 on 3. So remember that we can view the gradient in a few forms, and one of them is looking at it as rise over run. Remembering that rise is our vertical and run is our horizontal. So I'll just write run and rise. That's y and that's x. So looking at this particular gradient, remembering that it's rise over run, so the rise is 2 and the run is 3. Now let's go back to the coordinate we found in part 1, which was 0, 2. So point number 2 tells us that from the point 0, 2, so starting from there, and next point has run 3 units, so it's moved 3 units across the horizontal, and it's risen 2 units in the vertical. So when I say it's run 3 units, so let's say it started at 0 and it's run 3 units. So that means it's gone plus 3. So our new coordinate is when x is equal to 3. So just write, because remember, this is our run, and run is our horizontal. Then we've got our vertical, so which is our rise, and we started at 2, and we've ended, we've risen 2 units, which means we've moved up 2 points. So 2 plus 2 equals 4. So that means our new y value is 4. So that means that our new coordinate is when x is 3 and y is 4. So from 0 to our next point is 3, 4. So now if we look at our Cartesian plane, or if we go to plot it, so I'll just write here, arriving at the point 3, 4. So if we go to graphing our Cartesian plane, when y is 2, say it's about here, and then 3 would be about there when x is 3, and when x is 3, y is 4. So I'm just going to draw my point here. Yeah, and my point there. And now what I'm going to do is connect the 2 lines, the 2 dots as they lie on my line. So like before, really important to label your coordinates. So we've got 0, 2 here, we've got 3 on 4 here, and I'm just going to write the equation as well. Now this method, and that's it. So with this method, it does take a little bit of time to really break down what's going on. You need to make sure that you can comfortably identify what the gradient is and what it does to a particular point. So I'm in another color, we'll just go through the rise over run bit again. So remember, we started at 0, 2, and remembering that our gradient is 2/3, so we've risen 2, so we rose 2, rise of 2, and then our run went from 0 and it moved 3 points, thus taking us from 0 to 3. So this is just a visual representation. Obviously, we had to actually work backwards, so we had to work out what was going on and find a new coordinate to then graph. So just take your time, and to check whether or not you did it correctly, always a good idea to just take a look at your graph and see, does it match up with what the equation is asking of us.